Right, good morning, everyone. Right, today we are meeting in order to make sure that we iron out in terms of our understanding with regards to assembly drawing. Right, this is a revision exercise. We are going to look at mechanical drawing and in particular, its assembly drawing. Like I've already stated, mechanical drawing, assembly drawing is question 4 of paper 2. It's a revision exercise and it's from a past exam paper. Right, of course, in this one we are looking at it's from one province in terms of their trial exam, but we all know that these trial exams, they are extracted from past exam papers. Right, we want to look at approaches and application with regards to assembly drawing. So let's pay attention and make sure that we understand. Where you have got any queries, you are free to raise those so that I can respond to you accordingly. Thank you. I want you to enjoy this lesson. But before we go straight to our lesson, right, let's look at these important words. I hear and I forget, I see and I remember, I do and I understand. This is taken from Rotary in 1977. Right, these are very important words in terms of technical subjects, in terms of practical subjects. You need to make sure that you understand what you are doing, and that can only be possible if you do the exercises. So let's make sure that we apply what we are learning, and application is by doing. Thank you. Enjoy the lesson. Right, like I've already alluded to, we are going to look at assembly drawing. Right, we have got today, this is the paper that we want to look at. All the details that we find here, the question would be, question number 4, mechanical assembly given the exploded isometric drawing of the parts of a float control assembly, showing the position of each part relative to all the others. Orthographic views of each parts of the float control assembly. Right, the instructions are as follows. Answer this question on page 6, which is our page 6, which is here. Draw to scale 1:1 and in third angle orthographic projection the following views of the assembled parts of the float control assembly. A sectional front view on cutting plane AA as seen from the direction of the arrow shown on the exploded isometric drawing. The cutting plane is shown on the right view of the inlet. Right, so there is our cutting plane. This is the inlet. So we are going to make sure that every part has to be cut according to the cutting plane, which is indicated. Then we are also supposed to draw a right view as well as a bottom view, right? This is somewhat extraordinary because we are normally used to the top view instead of a bottom view. Planning is essential. All drawings must comply with the guidelines as contained in the Science 10.1.1.1. The convention of symmetry may not be applied. Show 3 faces of the inlet in the bottom view. The plug part 4 must be placed against the jet. So we have got the plug, which is part 4, should be placed against the jet. So what it means is that, right, either this side should be in contact with that. That's add cutting plane AA in the right view. No hidden detail is required. Now, before we start drawing, as you have already noticed, that planning is very essential, right? So what we want to look at this point, we want to find the total length, right, in terms of the paper, right, in terms of the drawing when everything has been put together, right? So if we look at this, right, we have got the inlet, we have got the the valve body, right? The valve body, which is here, it says from here to there, that's 104, right? Then it would get into the inlet, right, which is 58 millimeters, okay? Right, but if you check, the inlet would go into, the valve body would go into the inlet by 16 millimeters. So what it means is that in terms of the total length, we are going to say 104 minus 16 plus 58. Let's do the calculations. Right, if we say 104 minus 16, we'll get that, plus 58, we are going to get 146. The 146 is the total length with regards to our front view, with regards to our bottom view. So the next thing that we also need to consider is the issue of the total height, right? That is the height in terms of the drawing that we are going to work on, right? We would consider certain views in order to establish the total height. We would consider the height, which is given as the across plus. So the height is basically 76 divided by 2 plus, right, the distance from the center line, which is 53, right? So we are going to say 53, which would give us 76 divided by 2, which is 38, plus 53, which would give us 91. So the overall size in terms of our drawing is going to be 91. Right, then we look at the overall width, right, the overall width, right, if we look at the inlet, right, it would appear to be the biggest part, okay? But we are not given the side of the hexagon. What we are given is the across diameter, which is diameter 76, right? So for now, we are going to use that as our tentative width, okay? Right, but we know that it will change, right, if we construct that. The size of this hexagon can only be defined by construction. So we are going to make sure that we leave enough space for that. So once you have gotten the total length, the total height, and the width like this, you can also now define the spaces, okay? Right, we need to measure from here to there to get the total length, right? Let's look at that. So we are going to measure from here to there. That will give me 21. All right, then we also measure again from here to there. It will give me 83. Right, so 210 plus 83, we get 294. At 293, right? So what we are going to do with regards to that, right, we are going to say length of paper minus the length of the front view plus the width of the right view, everything divided by 3, right? So 293 minus 146 plus width, which we said is 76, everything divided by 3, right? So it's minus 146 minus 76. We are going to get 71 divided by 3, right? We are going to get 23. So we are going to say 23, 146, 23, 76, and 23 plus or minus, okay? Right, from left to right. Then we measure that. Right, 23, 146. 23 again, then 76. Right, then we project this one up faintly. Project this one up. Right. So in terms of placement, we are going to have our front view, we are going to have our right view there. Right. Then we now look at the height of the paper. So we are going to say height of paper minus, right, the height of the front view plus the width of the bottom view. Okay, everything divided by 3. But let's look at the size of the paper from top to bottom. We've got 210. That's 32. Right? 210 plus 32, 242. Right. So we are going to say 242 minus the height, which is 91, minus 76 as well, which would give us 75, divided by 3, which will give us 25. Right. So we are going to measure from the top. We use this one. Then 91. 91, then 25 again. Then 76. Faint horizontal line, faint horizontal line. There you go. Right. So what it means basically is that we now have defined the space for our views. Right, we have got the right view, we have got the front view, we have got the bottom view there. But like we said, this is going to change, right? Because what we use is the across plus. Check something. This 70 or 76. I used the wrong one. Like that, because we should be able to create a square. Okay, the moment you see that you don't have a square, you should know that there's something which is wrong. I'm going to make this one slightly bigger, right, in terms of the mitre line, because we might need the space going out. Right, then we can also now even mitre from here to get to the midpoint. Right, not all the way like that. Take this one. Right. So from here to there, that's 70, that's 38. We can also need to measure 38 going down. Draw a line like this. Now, what is critical here? When we are looking from the right-hand side in terms of the inlet jet, we are going to see that hexagon, right? And the hexagon is defined by the across plus diameter, which is diameter 76. So we are going to stand here, right? Make this one is our center. Check this side. That's fine. It's fine. That's fine. So we are going to draw a circle like this, but not necessarily an outline. That is diameter 76. Right. Then we need now to draw the actual size. Right. In terms of that hexagon, we're going to do this. Like this. Right here, we draw a fade line like that. If we are satisfied, we can outline this and also outline that. Now we are defining our hexagon. There you go. Right. So that's the hexagon as it is seen from the right view. Right. The same hexagon now, we want to transfer it to the front view, also the bottom view. So what we can do, we take this one to the miter line, take it, and we do the same here so that we are able to see the three faces. That. We project. Just take this one up slightly. Now, if we check with regards to this information, we are given 58 from here to there. So we need to measure that 58. Right, measured from here. 58, the market point. Take this one up all the way. Right, and also the size from here to there. After measuring from here to there 58, we also need to measure 20, which we take from here back 20 millimeters. Then we draw a faint horizontal line. There is nothing that would stop you from outlining this from here to there, as well as outlining from here to there. This detail is not going to change, right? Neither are we going to change, but here it might change because we need to chamfer that, right? So we leave that one for now, but if it is a two-faced side, it's not going to change. Right, okay, so what we require now, right, we also need to project this for the center line all the way like that. But we need to construct, show the construction for the nuts. Take this. Take that. extend here, open to this point, and describe an arc. Also come here, do the same thing. Like that. Stand there, open to this point. Right, then it's 60 degrees to chamfer, like this. Outline that. We do the same this side. It's 60 degrees, tangential to the arc, into this line. Then we can outline that. Once you have done that, you can also now define this. That is the nut when it is seen from the bottom, and we can also close this. It's not going to change. So that is the nut when it is seen from the bottom. Right. The next detail that we want, right? If you look at this, there is that detail, right, which can be defined on the front view, right, in terms of the right view. So there's a front view, there's the right view. So that detail, we've got diameter 36, which is the tip end, then diameter 30, which is for this one, and then diameter 20. Right, so let's measure those diameters. 36, that's radius 18. Right, then radius 15 and radius 10. This detail will be seen right in terms of the front view. We're going to outline this. It's not going to change. Outline this one. So that is the detail that we are able to see when we are looking from the right-hand side. Right. Then this has to be projected to the front view, like that, not all the way. We only need it somewhere here. But this can be taken to the front. There you go. Right. The same detail, it can also now be projected to the bottom view. We take this. Then again, it will be taken to that. There you go. Right. We look at the information that is given. You'd find that from here to there is 20, and also from here to there is 10. So we are going to measure 10, 10, which is 20, 10, and 10. Then we take this one up. Right, in terms of the details, always, right, we see there is that, then it is taken down. this is what we are going to see when we are looking at the bottom. So we are going to create that shape as well. But with regards to the front view, right? Remember, it's going to be cut. So this is the 36 to the 30 to the 30 like that. Like this. We do the same. So that is the hollow part. This one is drawn all the way. And we do the same this side. But here it's just up to there because it's going to be cut. But we can now outline this. Right, so the approach is when you have defined a detail in one view, it should be related to the other views as well. Right, every part that has been defined should be found in the right view, in the front view, as well as the bottom view like this. Right, then we can also now do this. Take this one to there and take that one to there. So this detail which is here, it's now fully defined there. It's not going to change. Right, we do the same. But this one is going to result in a section. So we are not going to draw it all the way because some lines are going to be eliminated because of the exposure of the hidden details. So we are going to do this and do that. Right, at this point, there is nothing that would stop you from outlining from here to there, as well as from here to there. Right, that detail can be defined. Right. So we now have got our bottom view, right, showing the inlet, right, the right view showing the inlet as well, right, and the front view showing part of the inlet, but there is still other details that we want to insert, okay? Right, if we look at this, we have got this particular, right, detail, hidden detail, which we are going to outline, but we need to find out to what extent we need from here to there 10 millimeters, but 10 millimeters from the end. So we mark that. Then we also require 16 millimeters from here. Which is that. So we're going to do this. So this one would end here, 10 millimeters, so we can outline this. That is for the hollow part, we can outline that. It's not going to change. Then the other detail that we require now, if we check with regards to this, but you'd find that this is in line with that detail, right? This is also in line with that. So what we need, right, is to extend this one to there and extend this one to there. So that part can also be defined. Let me just do this. Outline. Outline like that. Now, we are done with regards to the information which is here, but we can also close this part. Yeah, like this. Right, it's not going to change. Right, then what is going to be assembled? We have got here the seal ring. The seal ring is going to be inserted such that it will be accommodated by that part of the inlet jet. Right, so remember we have exposed this one, which is now outlined. Right, so this part is now outlined, 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 and the diameter from here to there, right, it's a diameter 30, okay? It's diameter 30, and the outside diameter is diameter 42. Right, and the distance from here to there it's 8, and the distance from here to there is 2. So what it means is that this part is going to be 6. So we can measure now from this point 6 millimeters, but we need 8, which is this. Then we take this one down. Take this one down like that. So from here to there it's 2, but from here to there it's 8. Okay, right. We also require 42, right, just to make sure that that is in position. 42, right. Maybe let's do this. Show the center line. And also the center line here. But we can also define the center line here, which also would translate into a cutting plane. So center line. Show it at the top, a thick end, and also a thick end like that. Then we bring this one. Let's thicken at the end. Thick ends, right? So we have that. Then we can label this one A. A, that's our cutting plane, okay? So the cutting plane is already in position, right? So we need now to measure from here to there 21, and also measure up there also 21. So we have got 21. As well as 21, which is 42. In case we might need this detail, we just draw it all the way like this, all the way like that. So what we have now from here to there, as well as to that part, we have now that detail. Let me just verify. It has to be 21. Right, okay, it is. So we can define this one, outline from here to there. So that's the seal in position, right? And we can also remember it has a through hole of diameter 20, right, like that. Right. Now, if we look at this, right, which is the inlet jet, okay, right, would also see that it has been, right, if we look at that, right, we would also see that it has been, there is this part which is also linked to the valve body, right? Remember, in every exercise that we do, right, sometimes we also need to make sure that we plan and we work on it in order to make sure that we are bringing to you the right knowledge and everything. So we take this one now, we insert it here. So the valve body would come also and be fitted into, right, into the inlet jet. Right, it will be fitted into the inlet jet like that. Right, so what is the size? You see that it's from here to there, it's M64. Okay, from here to there, it's M64, which is from here to there, which is M64. Right, so what we need to do is to measure, right? We measure 64, that's 32 by 3. So we need this 32 like that, then 64, which would be here, this. Don't think it will go all the way like that. Then we need 3 millimeters in terms of the thread depth. Okay, so it's M64 by 3. We also come here and measure 3 millimeters like that. Then we also take it like that. Take it like this. Right. So that is the extent. Remember, from here to there, that's 16. Right. But if we look at this size, from here to there, that's 19. So if we measure from here to there, 19, let's see what it would entail. It would come here. Okay. We also need that information right at the bottom. So I'm going to project like this. What it means basically is that if we miter to create that, right, we are going to do this and also miter this sign, we find that it will be one and the same thing. This can be outlined because now this is the valve body in position inside the inlet jet. So it can be outlined like that. We also come here and do the same thing. Right, like this, we outline this, and we also do the same thing like this, outline that. Then we can complete this and that. Take this one all the way. Like that, and close this part. This is about the inlet jet now, which is accommodating the, right, it is now accommodating the valve body. Okay, if we measured from here to there, 32, right, and also 32 on the other side, because it's a diameter, we also need to come and measure 32 this side, which is here, and also 64, which is there. Right. At this point, we miter like that at 45 degrees, and also at 45 degrees, so that we get to this point. Let's see if it is 64. Yes, it is. So we need this outline here. Outline there. And so then we can also outline here. Like that. And we project from here. We also do the same in terms of the upper part. We project like this. We also project like that. Right, and we go to our paper. Right, we go to our paper. Right, after the 19, which is here, we measure 40, 43. Right, then we miter and we miter like that. Right. So let's measure 43. We can measure even here at the bottom, 43 market point. Take this one up. At this very point, we need 45 to miter like this, and also 45 like that, and also 45. There you go. We also need 45. Right. Where would the 45 take us? Right, it would take us to the 42 millimeter mark. Okay. Remember, at some point we defined the 42, which is 21 from here to there. So we have got this, which is that one as well. So we are going to project this, take this one up. So at the bottom, we now have got this, and that should also be equal to 42, which is exactly that. Right. Then we take this one, take this one as well. With regards to the bottom part, it's not going to change, right? Because there is no section to talk about, right? We are also going to do this. But we cannot outline from here to there because there's still other detail that is coming, but we can do this. We can also do this like that. Remember, every detail that you have defined in one view, every detail that you have defined in one view, right, should be seen, right, in all the views. Let me just show you like this. Right. So every detail in one view should be seen in all the views. Right. So even here, if we project like that, right, it's not going to be affected by anything. So we are going to outline from here to there, right, and also take this one back now to the. Okay, but we are not going to draw this because it's cut along the halving part. Okay, right. So we are not going to define any detail here because it's a right way they are separated. So there is nothing that is cut. It's only separation which has taken place. The next thing that we want to look at, right? We are looking at this part, right? Which is the part which is 53 millimeters going down, right? It's 22 millimeters from the 19. So let's measure 22. The 19 is here, so we measure 22 millimeters, which is this point. So we take this one down like that. This, we also know that the diameter of this is radius 10, which is diameter 20 like that. Then the inside it's radius 5. Right, so we are going to measure 10, right, and also measure 5 millimeters. Okay, but remember this is our center line, so we can take it all the way because we need it in both the front and the bottom view. Right, then we come here, we draw a circle, that is the diameter 20. But we also draw another circle. So that is diameter 5. Diameter 10, radius 5. We take this one up. Right. The moment we have defined this, we've taken this one up. So we also need to take this one up as well. Like that. Okay. Right. Then we also need to take this. Right. It's already there. It's already there. But this inner one is not important because we are not dealing with hidden details. So we want this, we want that. We come here and we define this, and we define that. Every detail in one view should be represented in all other views. So we close that part. Right. So in terms of the right view, right, it's almost it's done basically, because we have got this lowered part is there. We have got that which we are looking at from this side, which is this hollow part is there. That part is that one. Then the raised part, which is that one as well as the hexagon and the cutting plane. Right. The next thing that we would want, right? If we check here, we have got this point and that point. That's not going to change either. So we are going to outline from here to there, right? We are also going to outline from here to there. Just check from, remember we planned this week. Like that. Every detail that can be defined should be defined. Just wait. If you are not sure with certain other details, that's what you should wait for. Right. If we check with regards to this, right, now we are here, okay, right, which is also that, right, but what we need to do now is to make sure that we are also able to define, right, we take this one now, which is the retaining ring, and it is positioned there. The diameter, inside diameter is 24, that's 24. The outside diameter is 34, right, which is 34 there. So we need to measure that. First of all, let's measure 15 from this end. 15, that's 15. Draw a faint line going up like that. But what I can do so that it is easier to define, let's also define the center line. Yes. And also show the center line here. Yes. But we can also show the center lines here, like this. Right. Wherever there is a circular part, you need to define that by way of the center line. Right. Then we need to measure 34, which is 17 either side. 17. Mark there. There. This detail is not going to change since we don't require hidden details, right? Then we also have got this, which is the 40, 42, right? Then we close this part, which is from here to there, that's 34, from here to there, that's 15. Right, we can take this one now, there. We can also take this one now, there. But we are not going to define anything because there's still some details to be shown. Now, what we have done here, we can also do the same here, right? But first of all, we need to define that diameter 24. Then we bring this one now in position, which is diameter 34 and diameter 24 inside. So first of all, it's 12. That's 12. Let's see. Correct. We can just make this one slightly longer in case there's certain details that we may require, which like that. Then we also measure now 34, which is 17 and 17. We can even outline this detail, it's not going to change. Right. This one, to the top especially. Close this. So close this. Right, this line was not supposed to be there. But this we can outline, this we can outline to show that this one, like, let me see if I do have ways of erasing that. This one. Right. We can only see that there's a hidden detail behind, but from the front side, right, it won't be visible. Now, once we have done this, right, the next thing that we can also go back and define, right, if we are looking at the seal ring as well as a jet, but we have got diameter, right, we have got diameter 42, right, which is also diameter 42. So this would be in contact with that, right? So what is the size? We need to measure from this point, right, 28. Let's measure 28. That's our 28. But we don't need this information at the bottom, so we are just going to relate to this one. So looking at this, we have got from here to the 10 millimeters, then also from here to the 8 millimeters. So there is 10 and 8, then diameter 4. So let's measure from here 10 millimeters. It's already there, which is this one. With this. Right. Then we need 4, which is 2 millimeters. Also 2 millimeters there. We may need this information there. So like that. But let me verify again. Should be 28, correct. Then we have got 10. So this would be taken to them. There's nothing that would stop us from outlining this. Is there both 42 and 42, then we connect to this one. Close this one. Right, then we have got from here to there, that's 12. Right, then this diameter 20. Okay, so we are not going to worry about that. So let's measure 12. Like this. Measure 8 millimeters, which is already there. So we have put it that, we have put it that. This is connected to the diameter 20. Outline. Then we also outline here. We also outline here. Every hidden detail that has been exposed should be outlined. Then we do this. We also do that. Right. That is now the jet in position. Right, we shall see it more clearly, right, when we provide the hatching details. Then we now need to look at this position, right? It's from the center line and that center line as well, right? So where the two lines are meeting, which is there, right? We have got a pin diameter, right? Diameter 6. So let's draw that pin in position. I'm going to do this. That's the pin in position. I'm going to hatch this one even now. Because it has been cut across. So that is the pin in position. There are so many things that we are going to draw related to that pin. Okay. Now, if we check with regards to this detail, right, this is the diameter of the pin, so we need from that point radius 9 as well as radius 10. Right, radius 10, which is here, and also radius 9, which is there. Take your canvas. This. Right, then we go to radius 10. Take this one and we bring this one down like that. From the detail, it's diameter 4, right, and it's 15. Right, so we need to measure from here to there. 15. Right. Then 4. Which is there. Take this one. So we are going to outline from here to there. And from here to there as well. Close this. And also close that part. Right. Now, if this part is not going to change, right, the material application of the function in terms of how it works, right, you can leave this one unhedged, right, but again you can also draw it and hedge it at the same time. But because this one is not going to change so much in terms of how it will be seen, right? So you can leave it unhedged even though it is cut like that. Right, I'm going to project this one up. This one is already projected. So from this point, you measure 16. 16, then radius 7 is 16. Radius 7. This. Do this. So then take this, which is radius 10, stand here and mark. And take this one as well. That's the center line. And draw this. But that would blend with that part. You take this one down. And you also take this one down. So I'm not going to hedge this one, right? But again, if you want, you can also hedge it, but you are going to lose identity of this part because this is circular. This one is sort of just a piece of material with a thickness of 4 millimeters, but this one is a diameter. So if we hedge, it will appear as if it's just one thing like that. So we are going to leave it like this and show the center line here like that. Also come here, show the center line like this. Let's show the center line, and also here. So there you can also show center line. Like that. Those are the center lines which are required. Now, if we look again at now, if we project, but we can now project from here like that. Then we can also project from here like this. Then we can also project like that. Then last but not least is this one. Okay. But we know that the thickness is 4 millimeters either side, either way, right? So we are going to measure 2 millimeters and 2 millimeters this side. Project like this. Now we can outline up to this point, yes. Then this one. So we can also outline here. Right. We can also outline here. Right. And last but not least is that one. Now we can go back to our diagram and do this. And we can also do the same. This. Now, remember we are supposed to see from the bottom. So this detail of that one is here. This detail of that one is there as well. Once we have defined the extent, we can also now outline from here to there. Also do the same, outline from here to there. Right, the next thing that we want, right, in line with the 42, that is where this part would end. Right, that's still 42. Then we have got the distance from here to there, that's 41. Okay, right, but which is 42. So from the 19, we mark, that's 41. Take this one down, like that. To this one. This one is that. It's 42. Then we have got 24, 24. So we are going to take this one like this. Always. But we've got 38. All right, once we have measured that, we need 38, which is this part. We take this one down like this. And to there. And to there. Connect to there as well. All right. And we close this part. There you go. All right, we close that part, slowly taking shape. Right, as you can see, with regards to the bottom view, it's now complete. We have got our center lines, we have got all the details. This part is that part, this part will be that part, and this is that. Then we have got this, which is the 42, partly seen like that. Then we have got the 34, right, where we are not able to see the diameter 24 from the bottom. Right, so the bottom part is complete. Right, remember what is critical, whatever detail that we have here should be also be reflected there and there as well. Right, then the next thing that we want to insert, right, is this plug. Okay, right, you would see that this, the height is 24, right, so it's still going to assume that one. Then the distance from here to there, right, that's 7, right, that's 7 millimeters. So I'm going to measure 7 millimeters from here to there. Right, I'm going to mark this. Right, then I put 33, which would come here. 33. So this taken up like this, outlined. And then take this one. Let's see what is the height. Right, the height is 17, that is 17. Right, remember from here to there, that's 17, and we also now need to measure from here to there, 17. Let's see. 17. We need 17, which would go up like this. We close this part. We close that part as well. We also do the same because they should be in contact like this. There you go. Right. So now the the float trigger is now in position, right? We have got the retaining ring, which is also in position, right? We have got the seal ring, it's also in position. We have got the jet also in position. So the only thing that is left now is for us to do the hatching, but I'm going to hatch this. That is the retaining ring. That is the retaining ring. Right, like I said, I'm not going to hash this in order to maintain the identity of all the parts. Right, this part, right, remember we said that it is basically separated along the cutting plane. So it's not cut, but we are just going to show that those are threads. Right, but we can also show the hatching for this. Is the plan. So that's the plug in position. Right, we also look at this. Let me hatch it like this with close the lines. Right, we can also hatch this one. Right, last but not least, we can also hatch this, but it will be ideal. Make bigger hatching lines. Right. Now we have got everything that needs to be hedged, having been what? Hedged. Right. So if we look at this in terms of our diagram, okay? Right, we have got our right view, we have got our sectional, full sectional front view, we also have got our bottom view. Right, so what is critical with regards to all this is to make sure that you know how to represent the fasteners in their conventions, you know how to represent the threads conventionally, you know how to represent each and every information that has been given to you right? Without even thinking about it, just make sure that you are able to do it. That is the application that we talk about. So there you go. We have got our assembly drawing, right? I hope this would assist you in terms of your revision exercise, in terms of treatment of components, right? But we still have got this other detail that we want to factor in, though it's not going to be hatched, right? Okay, but remember this, we need that, and also we need this one as well, right? That detail is not going to be hatched simply because it's not cut, okay? But it's part of the valve body. But so if we are looking at this, we are not going to cut anything because that is the point of separation, right? So we are done with that part, right? So the hatching, like I said, you could still also hatch that, but you would lose identity of this part because it would appear as if it's uniform throughout. So just to retain that by the mere fact that you would show a center line here and a cross like that, it shows that this part is cylindrical, but the other one is just a piece of material, right? Like a sheet material, something like that. Right, okay. So we have got that one as well. Right, so this is how we basically treat assembly drawing. Remember, center lines are important for every circular part you need to define by way of a center line. Thank you. I hope you enjoyed this lesson, and we'll see you again on Monday. Thank you. Right, enjoy the rest of your day. Goodbye.